to the third part video of week 4, which we'll be talking about arrays and vectors. So I asked you guys, what is an array? What is a vector? As far as you remember, it has a starting point but ends eternally. A tail and a head, direction and mag. Oh, vector. Okay, I see. Yeah, so I mean, you can think about it from like a math perspective, I guess, like that. And that does make sense when you say it like that, Buraf. So like it has a starting point but ends eternally. So if we think about that, have you guys used arrays before in Java? An array and a vector, yes, you have used them. Cool. So they are basically ways of storing complex data. And complex data is, or compound data, I should say, is other data types. So we can store, say, if we have a list of test scores, an array is a fixed size of elements. So say we have, I know I have 9 participants in the classroom right now. So I would make an array and define it of a size of 9, and I can store 9 values. All right. The problem with arrays in C++ is once you define the size of being 9, you can't change it after runtime. So if I had a student that dropped the program or actually decided to take the program and now I have 10 students, my array won't dynamically grow. Whereas a vector, like you said, will have a starting point, but it can keep on growing. It can end at 9 or it can end at 10 or 11, and I can keep dynamically populating it. So you might think to yourself, well, why are we even learning about arrays if vectors are basically way better? Yes, exactly, like an array list. So you guys have probably used arrays before, and you know that they're fixed in size and there's limitations to them. And sometimes they are better to use than vectors, and I'll explain in a little bit. But array lists, much like vectors, C++ just uses a different name. They're dynamically populated. You can add to them at runtime, and you don't have to define or initialize things to a certain value, whereas with arrays you do. So we'll talk about that in a little bit. But an advantage to arrays versus vectors is arrays are much more efficient because they know the size in memory, and it's a lot faster to get your data. So if you had a really big program and you knew that you could use an array versus a vector because that size or that element list would always be the same number and you don't need to dynamically populate it, then you would use an array. Most of the time we will use vectors. So another perk of learning arrays right now is because there's a lot of legacy C++ code out there, and it will make you a better programmer in general to know about them, how they work, and to be able to read some of that code. If you do come across it, you'll know how to use an array or what is happening with that array. Cool. So like I said, we'll start with arrays and then I will move into vectors. Okay. So an array is a compound data type or data structure, which basically just means it's a collection of elements. It's a data type that's made up of other data types. So like test scores, it's made up of integers, right? So all elements have to be of the same type. So all ints or all strings or all doubles, and each element can be accessed directly. So you can get the third element or the fourth element. You guys know all of this stuff. A reason why we need them, basically if you had 100 students, you could write out each test score as its own variable. But if you had 100 students, that would take forever. So arrays kind of solve this problem by making it a lot easier to make bigger lists of stuff. So some characteristics of arrays that you guys should be aware of. They're fixed in size. All the elements have to be the same type. They're stored contiguously in memory, and individual elements can be accessed by their position or their index. So as you guys probably know, arrays start at position 0, not position 1. And that can sometimes trick beginning programmers. So whenever you want to get the first element in the array, you have to actually get the element at position 0. So here we can see, if I annotate this, this is position 0. This is the first element in the array, but we start it at 0, then 1, then 2, then 3, and so on. So there is actually 10 elements in this array, but they go from 0 to 9. All right? That's just a programming thing to keep in mind. The last element is always the size of the array minus 1. So if this is 10 minus 1, then it's 9. Another problem with arrays is there's no way to check to see if you're out of bounds. So this only has 10 elements, but if I tried to get, say, test underscore scores at element 10 here, so this array is called test underscore scores. And I know there's 10 elements, so then a beginning programmer might make this mistake. I want to get the last element in the array. I might want to get 10. But remember, it's 0 to 9. So there is no 10. There's nothing here. So basically, I'm out of bounds. The bounds of the array are 0 through 9, right? So if I'm out of bounds, there's no exception handling by default in arrays. There is in vectors, but there isn't in arrays. So it'll just kind of give me junk. It'll just give me, like one of those 739 times 10 to the power of negative 392 or something. And it will just like make up a gross number here. It won't even give me an index out of range. Vector will, but an array won't. With arrays, we always have to initialize them, so you can't just set it to nothing. Or if you don't initialize it, it'll just fill them with junk numbers. It won't fill it with zeros. So they're very efficient. They're very fast because they know exactly where in memory to get it. They use math to get basically a place in memory, and then it uses the size in bytes. Let's see if I can annotate this. If each of these ints is, say, 8 bytes, this array, if you tried to print the name of this array or the value, say it might come out as value 1000. Like that's literally the memory storage area value of where it is in your system memory. So this is 8 bytes here, right? So every 8 bytes, this one might be 1000, and then this one is 8 bytes after at element 1. So it might be 1008. So it knows that each thing is 8 bytes apart because they're all ints and they're all the same size. This one might be 1016. Whoops, typed that wrong. And so it knows I'll just skip to 1016 if you want the second element because everything is 2 bytes. So they're very fast, very efficient, and you can use looping often to process through arrays. Cool, so just remember, we can't change the size dynamically. So if you do want to change the number, you'd have to stop the program, change the number, recompile, and then rerun the program. Cool. So how do we declare an array? We use square brackets, very important. So you do the element type that you want in the array. So if you want it to be an array of integers, you do int, then the name of the array. So for this example, it's test scores. And then you tell it the number of elements you want in the array. So 5, if we want 5 test scores or 5 students that we're tracking their test scores for. Cool. The size is fixed in the square brackets, so this has to be set correctly because then the compiler will use that size to know what size to make the array at runtime. It can be a constant literal, it can be a declared constant, or it can be a constant expression. It just can't change. So here you just type the number 5. Here I made int high score per level and I typed 10. Or here we made a const int days in year 365, and then we pass the days in year as that size in the array. So because this is a const, I can actually pass that variable name as my array size because it won't change, right? So you can pass, you don't have to just pass it a number, you can actually pass it a const as well. None of the arrays in this example are initialized, which means the contents are actually empty. So I have an array that I am saying there's 5 elements in, but I haven't told them what the value is. So basically right now, there's just going to be garbage in there. It's not going to be anything. So the best practice is to actually initialize them. Same thing with variables. You know how we got compiler warnings when you don't initialize a variable? It's best practice to initialize arrays, and you'll see why in a second here. So to actually initialize them after we've declared them, you have your element type, your array name. So this would be int. That's your element type. The array name is test scores. The number of elements is going to be 5, as we can see here. And then our initialization list, you use curly braces for. And here we can see we've got 1, 2, 3, my drawing's horrible, 4, and 5. So you have to do the same size for initialization list. So those are my test scores, 100%, 95%, 99, 87, 88, right? Here, okay, if I re-annotate this, we have high score per level. It's an array list, or sorry, it's an array of integers. There's 10 elements, right? But I only initialized 2 of them. So I initialized 3 and 5. So what this would look like would be there'd be 10 elements going across like this. Okay. And the first two elements would be set to 3, 5, and then the remaining 10 would all be set to 0 automatically. Because we initialized 1, 2, 3, 4, 5, 8, 10, right? The remaining are set to 0. So if you only want to set the first couple, then you can set them to 3 and 5, and then the rest will be set to 0. That's just a handy thing to know. This example, we have double days in year, which is our const of 365, and then we're initializing them all to 0. So we only declare the first one, even though there's 365 elements in this array, they're all going to be initialized to 0. This is a very handy way to initialize all the elements in your array without having to type them all out like that. And this is used very often if you want to initialize them. Another way to do it is to let the compiler determine the size of the array. So it will base it off of the number of elements that you put in the initialization list. So in this last example here, we can see my square brackets is empty. I didn't put the number 5 like earlier. Okay, so here you have to make sure 5 matches 1, 2, 3, 4, 5. Here, if you leave it empty, and then you put as many elements as you want in the initialization list, so here there's 1, 2, 3, 4, 5, it'll automatically calculate that the array size is 5. So this is a really good way to do it too, because then you won't make the mistake of, oh, I typed 5, but I actually put in 6. So just another handy thing for you to know, declaring and initializing your arrays. Cool. So we've made it our array. We've initialized our array. Now we want to know, how do we actually access our array? So how do we print out a value in the array? It's pretty easy. So you use your square brackets, you type your array name, and then the index of the element that you want to access. So my array is declared as an array of integers. It's called test_scores. I set it to have 5 elements in it, and the values are 195, 99, 87, 88. All right, so remember, okay, they start at 0. So this is at index 0, index 1, index 2, index 3, and index 4. Okay, so I have to, if I want to print them out, the first score will be at index 0, and I access it by typing my square brackets, test_scores 0. Is this all very similar to Java for you guys? Some of this stuff might be a little bit different, like initializing them. Do you guys use the same syntax, or is it a little bit different? Just curious. Nearly the same so far, except for the initialization. Okay, cool. Yeah, so accessing them is very, very similar with the square brackets. Cool. If you want to change the contents of the array, basically what you can do is just use it the other way. So here we're printing them out in a cout statement. Here we have a cin statement, and then we're setting that value, test score of index 0, and then when you type test_scores 0 equals 90, then you're assigning the value of 90 to it, right? So same exact syntax, the array name and then the element in square brackets, but then you just hit equals, and that's what you're set it. Here we're doing cin with 5 different lines. So the user could type in 5 different numbers, and then they would all be set. And then here we're actually hard coding test scores at index 0 to be 90. So these would all be set based on what you type in the keyboard, and then right after that we would set the first one back to 90. Question, can we make an array a const? No, because it would have to be able to change. Well, I mean, you could make the numbers in the array consts, but you would want to be able to, you wouldn't ever be able to change the values of them, if you know what I mean. Like if you made them all consts, then all the numbers wouldn't be able to change. So if you wanted to have a list of consts, say you had like all these different mathematical operations like pi, the speed of light, the speed of sound, or something like that, then you could store them all in const array. Let me just look up the initialization for this. So you can just type it like this. So you do your const and then int and then your array with the size, and then the values, and then they can't change. So they would permanently be 1, 2, 3, 4, and 5. If you try to set it, so here he's trying to set this array called permanent at index 2, which has a value of 0, 1, 2. It has a value of 3. They're trying to change that to be 5. You get an error. Assignment of read only. So it's a read only array. It is possible. Yeah. Okay, cool. So there you go. So that's changing the elements if you want to change them. So just to remember, how does it work? The name of the array represents the location of the first element in the array. So behind the scenes, it's a location or an address in memory of that first element in the array. So remember, like I was saying, if you tried to print the value of the array, it'll tell you the address in memory. So for example, like I said, 1,000, and then it will use the size of bytes to mathematically calculate where the next elements are in the array. So the index represents the offset from the beginning of the array. So if you said you want to get something at the second index and the array starts at 0 and it knows all the element sizes are 4 bytes each, it'll take 2, which is the third index, and times that by the size of bytes and use that to mathematically find the value at that address in memory. So it would basically perform that calculation to find the correct element in the background, and it's very, very quick because it's doing that all mathematically. Remember, there's no bounds checking, so you can't actually go out of bounds. It won't give you an error. It'll just make up a number or give you junk kind of thing. The compiler uses that size of operator that we were talking about last week to determine the correct location. That's why arrays in C++ are so efficient. Cool. So let's go to CodeLight. You can download the code. It's the week 4 arrays main.cpp file in Blackboard. And we'll just go through some examples of some arrays. The first one here we'll talk about is a vowels array with all the vowels in the alphabet. And we'll talk about some examples, okay? And then we'll do a little in-class exercise together. So I'm just going to open it up here, week 4 arrays main.cpp. I'll make that my active project and scroll up to the top. All of this stuff is commented out, but we'll get to it eventually. Is my code big enough for you guys, or should I make my font size a little bit bigger? I can make it a little bit bigger, I think. How's that? Is that better? Hopefully this is helpful to you guys. If you guys already know all this stuff, we can kind of skip over it a little bit faster, but it might be a little bit different than what you're used to in Java, so I just want to make sure you guys know how they work. All right. Let me know if you guys are good to go by giving me a thumbs up or a little party emoji symbol when you guys got the code open in CodeLight. Yep, okay, awesome, Kyojin, thanks. We was ready to go, rad and awesome, you guys got it unzipped and imported into your workspace. Cool. So feel free to pause the video if you're watching this after and get that open and resume, but we will get into this first array called vowels. So I've got an array called vowels, and notice I haven't set it to a size. I didn't tell it how big the array was. I'm leaving it to the compiler to determine the size. I give it 5 elements, A, E, I, O, and U, and then I'm going to print out what the first vowel is, and then I'm going to do, remember, index of 0, and then I'm going to print out what the last value is, which is 0, 1, 2, 3, 4, and that should be the letter U. So if we just try to do build and run, I'll type Control F5 on my keyboard, and there we go. The first vowel is A, the last vowel is U. That's exactly what we expected. Awesome. Now, to show you, I'm going to uncomment this. We've got a C in, and then we're trying to save something at the 5th element index. This is out of bounds. So it should give us an error, but when I tried this, it didn't give me an error. You can see if it gives you an error. So I'm going to type a vowel, capital A, and hit enter, and it just kind of says press any key to continue. And it didn't give me an error like that. But it won't actually save anything there because there's nothing at that There's nothing at that location. If I try to output that, let's take a look at what happens. Nothing happens. It just printed out a little hyphen. So it just kind of garbage, right? It's incorrect. So don't do that. Don't access an element of the array that's at the wrong location or an index that's not existing. Okay, cool. I comment that out using control backslash, and then I'm going to uncomment these out. All right, so here we're making an array called high temps. And again, I haven't set it to a size, but I've given it 4 values here, 90.1, 89.8, 77.5, 81.6. And they're all doubles. And we're going to print out the first high temperature and then give it the index of 0. And then here we're going to set, okay, this is how we set a value. So what we do is we take that high temp 0 and then equal or set it to 100.7. So this is called an assignment statement. That's how we change the value of a variable at a particular index. And then we're going to reprint it out to the console and say what the first high temperature is now, and then we're going to reprint out at the 0 index what it is, and it should print 100.7. So first we'll see that it's 90.1. It's going to set it to 100.7 in the background, and then we'll see that it got updated. So let's print that, run our program, and as we can see, it's 90.1, and now it is 100.7. So it got basically changed in the background here to 100.7, and we reprinted it out. All right, so that is how you assign an assignment statement to an array. All right. I am now going to make an uninitialized array. All right, so here we can see it's an array of type int. It's called test scores, and it has 5 elements. All right, so I'm setting the size to be 5 elements, but I'm not setting them a value, right? Like I don't have my curly braces with numbers in there. So there's no values. So we're going to see what happens when you don't initialize it. Everything will be garbage data. Everything will be junk unless we actually set it to 0 or say 100 or 90. So we're just going to uncomment these couple of lines. And what these are doing is it's going to comment out what our first score is at index 0, 1, 2, 3, and 4. So I'll just do Control F5, and let's see what we get. You can see the first score at index 0 is 8, then 0, then 71, then 0 again. Then it's 1,246 or 12,460,816. So as you can see, it's always best practice to initialize our arrays because it'll just fill them with garbage data otherwise. All right. So here we uncomment these next 5 lines. What we want to do is it's going to print the garbage data. Then we're going to ask the user to enter 5 scores. And then using the cin and the insertion operator, we're going to set the scores at the indexes 0, 1, 2, 3, and 4. So if we run this, actually, it's asking for the 5 scores. So I'll do 10, 20, 30, 40, and 50. Hit enter, nothing will happen because we should have actually also uncommented these lines, which will print off what we enter. All right, so 10, 20, 30, 40, and 50. And then we can see the updated array is 10, 20, 30, 40, 50. So we have our garbage values, and then we have our actual entered values. Now, one last thing I want to show you. If we comment out this last line, notice the value of the array name is, and then we print out literally the array name test underscore scores. So we're not passing it in an index or anything. We're literally printing out the value of what the array is. So I'll do Control F5, and you will see what the memory address or the address of the memory location is 30, 40, 50 for that array. And we can see it is 0x6FFE00. And that is the memory address in our computer of where this array is. Cool. So you don't have to worry about that. You won't use this for anything. It's just interesting to know that that's how C++ or how the compiler finds where your array is in your machine. Cool. All right, so that is arrays. Hopefully that helped you guys. That's a little quick example of how they work. just reset that up so that everything's good to go in the future when I do that. Again, so cool. That's arrays. A little bit of an in-class exercise that I want you guys to try now is to declare an array of 10 integers. You can name the array ARR, or short form for array, and then initialize the array so that the 10 integers are all 0, okay? Then I want you to assign 100 to the first element of the array and 1,000 to the last element of the array. Okay, and that'll show me that you understand how the indexing works, how assignment works, and how to declare an array and initialize it. So work on this. I'll give you guys about 10 minutes, and then I'm going to get you guys to share your screens or show me how you guys did it and explain any issues you guys had. So just start a new CodeLight project, and then I want you guys to get this working. If you have any questions, I'll be here. But I will just share my screen so you can see the instructions. Cool. Does that make sense to everybody? Just want you to work on this to make sure that you guys understand how they work. Julio? All right, I will pause the recording here. Cool, awesome. Welcome back. Bura is going to walk us through his version. I'll stop sharing my screen, and then Bura will walk us through how he solved this in-class exercise. Thanks, Bura.
Okay, perfect. Can you hear me?
Yes, I can. Awesome.
Perfect. Let me just share my screen then. So can you see it?
Yes, yes, I can.
Perfect. So I just declared an empty array with the size of 10, as you told us to do. And then it's an empty array, so all of the indexes will be 0. So I just made the first index as 100 and the last index, which is the 10th element, as 1000. And I just outputted them all with cout. And as you can see, just a second, my computer is a bit slow. There we go. So the first element is 100 and the last element is 1000.
Great work. That's perfect. Awesome. Well done.
Thanks a lot.
Thank you for sharing, Bura.
You're welcome. Thank you.
Yes, and hopefully some of you guys were also able to get that done. But yes, that is a perfect way to do it. Great job. And in the future, we will cover, when you output it like that, using a loop, so you don't have to type in every element of the array. But for now, that is exactly what we've covered so far this year, and perfect way to do it. So thanks for sharing.
Yeah, I hesitate to use a for loop.
Did you originally use a for loop or no?
Well, I meant to do it, but I thought we didn't learn it yet, so it wouldn't be nice to use it.
Well, I mean, it seems like some of you guys are well ahead of some of the stuff we're covering. So I'm totally okay if you guys want me to move into some more complex stuff, then we totally can. But as this is an introduction to C++, I want to kind of move at a speed that's good for everybody. So I don't know, Simon there, he posted his code in the chat. So let's take a look at it. We've got using namespace std, int array. He sets them all to 0, and then he used a for loop, int n equals 0 while n is less than 10 plus n, and then he couts the array at the index of n, and then also outputs a new line. And then he sets array 0 element to 100, array 9 to 1000, and then reprints out the array. Yep, that's a perfect way to use a loop. Awesome. We'll cover loops probably next week. We'll see. Cool. I want to talk about now. So moving on past that, hopefully you guys got that working. The recording is going. Yes. Multidimensional arrays. Have you guys used multidimensional arrays before? So 2-dimensional, 3-dimensional arrays? Yes. Okay, cool. So basically, you have different dimensions. So you could use this, the example I'm using here is a movie rating system. So we have our first dimension size 3, and then our second dimension is size 4. So you can kind of think about it like columns and rows. So first one will always be the rows, and then the second one will be the columns. So here we can kind of see, made two consts, an int, rows 3, cols 4, and then we basically populated our two-dimensional array with our rows and then our columns. So we can see we've got 3 rows and 4 columns. So the way that this multidimensional array works is there's 2 dimensions. So one is the reviewer, and then the other dimension is the movies. So we can store all the reviews that a reviewer made for different movies. So say for movie 0, which could be the Titanic, it was reviewed by reviewer 0, and he gave it a score of 0. But then reviewer 1 gave the Titanic a score of 2, and then reviewer 2, or the third reviewer, gave it a score of 1. And then so on and so on. So we can see all the scores that the reviewer 1 made for all the different movies, or we can see all the reviews that a specific movie got from all the different reviewers. So that's kind of an easy way to imagine, a two-dimensional array. A third-dimensional array, if you want to, kind of get into it, it can kind of get a little bit confusing, but you can kind of start to imagine it like a cube going back, right? Something like this. And say a common third element in a cube could be time. And you could have, they could have watched the movie, say this row could be 2010, then they could watch the movie 10 years later and watch it in 2020, this row. And then, we could see what their review is for 2010, way back, for the Titanic from reviewer 0. And they gave it maybe a 4 back then, but now they're giving it a 0 in 2020. And then say back in 2010, we could see what movie 2 got from reviewer 3. It's just a common way to imagine, that's a 3-dimensional array. It kind of gets funky once you get into fourth dimensions and stuff like that, but you can make as many dimensions as you want. The same way we can access a multidimensional array is, just with 2 square brackets. So if we wanted to change the value, we can assign values using it the same way, and we can output values the same way. You just say row 1, column 2. So we would print out row 1, which is reviewer 1 at the first index, and then we would print out the movie 2, and we would print out 5 right there. So that's how you access and assign them. Another way you can initialize them is like this, with the curly braces, and then do each row with your 4 columns across, and it kind of helps you visualize, at least for 2-dimensional arrays, what's happening. All right, so we can see that these numbers correspond. Awesome. Any questions about that, or is that all good? It's all common knowledge by now for you guys with 2-dimensional arrays. That's good. All good so far. Awesome. Okay, so let's move on to vectors. So split this recording up even still. I'll stop the recording here